this to not happen when you have it equal to give you the wrong answer. So, just comment this out. Comment this. And let's take a look at what this is like. It's the same thing if, and then 3 and 9 I compare with 3 and 10. Wow, that is a lot easier. Cool. Okay. And then I have, and if that's the case, if it's greater than, then I write there in the output C1 greater than C2. And then to nest it, you have to say else if as one word. And then I do less than, and row 3, column 9 is less than row 3, column 10. Then I write C1 is less than C2 in my output. And then else, the third condition, because if it's not neither greater than nor less than, it has to be equal to. Then it will write C1 equal to C2. And you run that. Under this condition, it will give you the correct answer. C1 is equal to C2. And you can test it for the other conditions. C1 is less than C2, we'll call that 3 and 6. Got it? Which is true. And do 6 and 3. And run it. So it will give you the correct answer under any condition. So I should try running one of those and test it under all 3 conditions, see whether it works.
Once more, show how to change the columns to numbers.
Okay. When we're finished with this, I'll go back and go through that again.
Okay.
Remind me if I forget.
Max, can you repeat what the else if does?
Else if allows you to nest another if then else statements.
Oh, okay.
Else if, and then see, if you take the else off, that's just another if then else statement in there. So it allows you to test 4 conditions. So everyone getting theirs to run? And anyone not get it to run yet? Okay. So you've all got it to run and tested it on all 3 conditions, and it's working okay? Okay. Well, Linda asked that we run through changing the column headers to numbers again. So you go to File, Options, Formulas, and then you make sure that the R1 C1 reference style is checked. Okay, and it changes them to numbers. Did you get that? Okay, good. Okay, does anybody on this these really basic or fundamental? Sorry, I'm going to change that. These fundamental, the for loop, the while loop, the if then else, and the nested if then else. Does that make sense to everybody? Mm-hmm. Okay. All right. I'll close this out and take a look at some programs. First, I remember I was talking a while ago about the method. This is some height data. This is for another class, so don't worry about it. But this gives you the number of modes that exist in your data. And I'll do it for all the data because I've divided it between males and females. But what it will do is, this is the function that gives you multiple modes. Okay? And it will count then the number of modes. I think it's F9 that shows you exactly what they are. So I can highlight this. Yeah. Is that if you press F9, it tells you exactly what those modes are, and it will count the number of them. So this will tell you that you've got 2 modes. Likewise, this one tells you that you have 3 modes. And if you do an F9, it shows what those 3 modes are, 60, 69, and 70. I think that's pretty cool. Then when you want to, that's the program to, so that you can just copy that. I copied it to 1, 2, 3, 4, 6, 7, 8, so I could have up to 8 modes in my data, but it doesn't show anything in those cells where there aren't any, if I don't have modes to fill it. So what it does is that if the row from F15, which is this one, and then I say is great 2 F15, and here would be 2 F16, and so on, when you copy it, is greater than F13, which is the number of modes, then you write a space, in other words, an empty space, and you, let's see, you write, the index is to write the actual mode for your data range in the current row. So when you copy that down to the next cell, it just goes to the next, it increments these. This goes to F16, this goes to F16, but it goes to the next indexed mode, which I thought was kind of cool. I mean, it's kind of complicated, but you can get all sorts of stuff off of YouTube. And I went to Microsoft's website to try to figure out how to do this, and it was gibberish, absolute gibberish. I mean, their websites are incomprehensible. This was just some guy on YouTube that likes Excel, and it worked great, and it was easy to follow. So anyway, I thought that was pretty cool. Let's go back to let's first. Oh, let's look at the random walk graph. Do this one. What this one does is that I have to go into the program to tell it what distribution to apply to the angle and what distribution to apply to the length of the walk, and then the right parameters for each one of those, whatever the distribution is. So if I use normal, I have to give it a mean and standard deviation. If I use exponential, I have to give it a mean time between events. If I give it uniform, I have to give it a lower and upper range, that sort of thing. So it looks like normal ran okay the last time. I am going to do this.
Where did you say your upper bound of your upper and lower bound of your leg?
Did you say where?
Yeah, like because you've obviously specified that it can't be longer than.
Let's see. This one's normal, so let's go with the uniforms to see what I might have done it in the program.
Okay.
So this is an exponential and uniform. So distribution is uniform. I didn't give it mean and standard deviation. I did give it G. Oh, I think what the way I specified is that it was uniformly distributed between 0 and whatever the leg length was.
Okay.
So the leg length is 3, so I said it's anywhere between 0 and 3.
Okay.
So, first thing I did is I declared my variables and I initialized them. I find when I'm writing a really a more complicated program, what I like to do is declare the variable and then initialize it right away. And it's easier to keep track of. I think the accounting's easier that way, if I'm going to initialize it. This is how you declare a decimal number. You have to call it a variant, and then you have to take the variable name and tell it how many decimal places. So that's the precision, 27 decimal places. And then I initialized it to be equal to 0.
You know what the limit is on that?
No, I don't. Might be 27, but I'm not sure.
If you don't input anything, will it automatically default to the?
No, it has to have something in it. Oh, it has to have something in it. For some reason, it's picky about that. So X is the, and then these are all of my decimal variables. Let's see, this is exponential and uniform. So a lot of variables. What that first group does is it clears out. It clears the area so that it doesn't have any residual data now. So that's what all this is clearing the area. When I don't know how to do something in Excel, in the program, what I do is I record a macro doing the keystrokes. And then all I have to do is copy the macro and tailor it to my solution. Okay, and just paste it into the program. Because the macros always have a basic program behind them. So what this does is it will select B2 to B15, okay, to B15 here, and it clears it, and then it selects L3, which is out here somewhere. See, this when you're talking about literals, it will take it will take the letters.
Mm-hmm.
But when you're not talking about a literal, it doesn't do the letters. Here, this isn't a literal, so you have to use numbers. So it kind of goes back and forth. So most of the time it makes sense, but you might want to end up switching back and forth depending on what you want to refer to. So anyway, this is just kind of housekeeping. As you can see, I'm clearing the contents. I'm just selecting things and clearing contents so that you don't have any residual data that will get your program will use unintentionally. Okay. So then I write whenever I initialize the goal. G is the goal, L is the length of each leg, and A is the angle. I initialize that. I write it out so that I can remember what I was using. So here, my goal was I initialized 4, length was 3. And angle was 6.28. That's 2 pi. You know, so, I mean that's a crude 2 pi, but it's close enough. Mm. Okay, so but my angle then could draw somewhere between 0 and 2 pi for its direction. Okay, then I go for n. The largest loop is n, which I set at. 50. So this outer loop will execute 50 times. And then I said, while D is less than G, my goal. So in other words, this will keep going for each execution of this outer loop. This will keep going until I reach my goal. So however my distance, until my distance is equal to my goal. So as long as it's not equal to the goal, less than the goal, it will keep executing. I have all my length programs written here. So that I commented out. So in this one I did, I think exponential, this is exponential for length. So I commented out my normal length calculation, which I used my the polar method in here. I didn't use the norm inverse, just because I wanted to try it. And here, then I assign, given that, I assign my walk length and the angle. No, I didn't do the angle yet, that's just the walk length right now. So I write out whatever the length is, and also, so what was sigma? Must have been a good reason for sigma. So I can figure out what it was. Sigma times. Oh, sigma is the, it must be my z value. It looks like I'm writing sigma to 12, row 12, column 2, 12. Oh, okay, yeah, it's the standard deviation. Okay. So that's just to keep track of what my standard deviation is. That actually made sense, and I forgot that I did something sensible. And here I set sigma for equal to 1. Just random, it was just a value, a standard deviation of 1. And sigma 2 is a standard deviation of 3.14. That's for the angle. So it's a 1 pi standard deviation. Okay, so the exponential length, that's a lot easier. And so it's L, which is, it's negative L, which is the mean. And it's, and here I got lazy, I used the random number function in Excel because it was getting long enough and I messed around with it, so I just put the random number function over the log of E. Yeah.
Is there a catalog on here, like of every, like logarithms and natural log and stuff like that, just for the Visual Basic? Like does L, does that always mean the mean when you put it in Visual Basic? Understand what I'm saying?
I understand the first part of your question, but what do you mean L?
Well, you said you put the, or is L just?
That's just my variable.
Oh,
that's just my variable name. But for like these functions,
we get the functions in it. That's what I meant.
Yeah, to get the functions, I have actually been looking them up. I just type in a Google search, and I say what's the Excel function for, or the Excel basic function for. And then I'll name it, and usually I get it in the first get. Sometimes you have some trouble with it,
but there's no like catalog with like.
Not that I know of.
You can run it side by side with.
Not that I know of, because I'm sure you've tried to use the Excel help, and it's next to me. It's next to useless.
Excel.
It is useless.
Yeah.
Help. It's Excel. Shoot yourself in the face if you try to read it.
That's basically it. Yeah, I don't know why they can't write documentation, but Microsoft is awful at doing that. That's why I mean, thank heavens there's so many geeks out there that just love to do this, and put it on the internet. If it weren't for them, I'd never figure any of this out, probably. This is to convert it to log base E. That's why I divided it, because it only does common logarithms. I couldn't find the function for the natural logarithm anyway. It doesn't mean it doesn't exist, but if you take the log of the common log of your number and divide it by the common log of E, it has an E in there, but it doesn't seem to have the natural log. I mean, I suppose I could look again. I probably got lazy again and just couldn't find it, so I said, okay, I'll use the common log. But really, this is just the natural log of the random number. That's all that is. So that's to generate the length, the current random variable of the length. And then for the angle, I used uniform. Oh, that is this current one. I used uniform, and all I did was angle is the random number times A. So it's some fraction of 2 pi, some random fraction of 2 pi. That's all that is. The uniform ones is very easy to use. So anyway, then D is whatever the current D is, in other words, my current location, plus my walk length, times the cosine of the angle, so that I can get the horizontal. The cosine gives me the horizontal one. And then This was just some ledger domain that I needed to use. But then I write out whatever the current value of C is, which is, oh, here. The current value of C, which is the maximum integer. It's the maximum number of the current run. And the maximum value of X, which is the maximum angle, I think. Maximum length, okay, and the minimum length. So, I documented it just so I could get it, and then prepare for the next iteration. I re-initialize all my variables, set them back to 0, and then I make sure that the contents are cleared of this section right here, because I need to clear that out just in case the next run is shorter. Because if the next run is shorter, then it gives me the wrong answer, so it has to be cleared. It looks like I'm ready to go, so let's try that. Okay, this is the number of iterations that are running right here. Like I said, if it gets up to 35,000, it just shuts off. Excel won't take any more than that. So this is an exceptionally long run. And I tried to get it to pause in between each run so that you could see a graph of every one, but I haven't solved that yet. So all I can get is the graph of the last iteration. See, that's what it's doing, it's clearing it after it runs it. Now we got a long run again. That's usually what happens. You have a bunch of short runs, then a long run, and then a bunch of short runs, then a long run.
We did something like this in college, and we had to hit run. Our teacher told us, because he knew the laptops that we were using, he told us, like, you have to hit run by about 7 p.m. tonight, otherwise it won't be ready for class tomorrow morning.
Interesting you should say that. When I was writing my dissertation, I ran DAX Fortran for my dissertation, and then statistical analysis and graphing I did in SAS, which was also based on the DAX mainframe. And what you had to do is write a batch file so that it would start executing at about 1 o'clock in the morning. Otherwise, it would take all day because everyone else was doing it. And see, it's run out. It's about 32,000 that it gives you a runtime error. But anyway, it's ended. And this is the last one that they gave you an error. They gave an error. That was 32,000 legs, and he just our walker just ended up out here in Neverland and never came home and never made it back. And that happens more often than not. There's a few that will never do that. That will never get a runtime error. And those distributions are, let me see if I can remember. No, I didn't document that. Because what I did is I ran every one. It's possible to run every one of these often enough so that you can get 50, but there's some of them, and it's too long since I did this, I don't remember. But some of them, it takes a lot to run before you can get all 50 iterations. They time out like that. That is a typical run for something like that one was normal uniform. Or exponential uniform, wasn't it? Yes. Yeah, exponential uniform. And uniform is a little bit simpler to run, and that one I think that very rarely maxes out. That's a typical run right there. Is to start up at the origin. and then wanders, and it very frequently wanders after. But that, I mean, that's, if it's going to have a lot of runs, that's the direction we're going, because if it starts doing that in the other direction, you hit your goal. So you'll never have that kind of a pattern on the other side unless you set the goal to -4. If I set the goal to -4, then you'd end up with a mirror image of that. So that's the random walk. Let me say that. Okay, there we go. All right, so this is, you have some, a random number generator that you can use as part of your homework. And that's what you can do, work on for next week, because that'll help you for the next exam. And we'll take a look at random. This is, and you can make keyboard shortcuts for these too, just so you know. My declarations and initialization, 500 random numbers. So I look to row 5, column 2 for my seed. So row 5, column 2. And that's Z sub 0, that's the seed. That's what that's doing, is it's picking up whatever seed you put into your program. The reason that this is, and this is the format, R1C1. That's why it's all formula is always R1C1. So if it's not value, see that's value. If it's not value, it's a formula. That's another option, let's put it that way. And the formula is just that picking up the value that's in that cell. Then the next formula is to 1 to n, 1 to 500, we're generating 500 random numbers, and we're incrementing the row by the current value of y. And this is the formula of mod, the mod of the modulus of the previous z number, the previous z sub 0, and adding the increment, and that's the modulus location, I believe. So what we have here is, in the second column is the uniform random numbers, and the first column is that modulus. It's the modulus of V4. It's in V4. It's the modular function of the modulus, which is in row 4, column 2, or V4. And so it's looking there for that particular modular, that modulus to run the modular function. And then you take B2, which is C, and multiply it by A9, which is the current Z value, and add B3, which is C, the increment. And that's where this formula is programmed in. That way. That's this. Mod, so you take this and multiply it by the modulus of n. That's what that formula does, the way it's written there. And then to produce u, you just take the current z value from that and divide it by the modulus. And like I said, I didn't name this. I apologize for that, but the variable name is modulus. The function name is modulo. And so, and the reason that they call this the modulus is because it's the one that you take the modular function on, I think. The words didn't help things. that's the way they chose it. That's the way it's named in the literature. So we go back to this, And so what that does is it takes the modulo, it does the modulo function on this and multiplies it by that. And then in the next column, it takes this result, in other words, it takes the result in the same row in the previous column. This is a relative statement. So it goes current row, previous column. So column in square brackets -1. So it looks in whatever row it's already in the previous column, and divides that by row 4, column 2. Row 4, column 2 is the modulus. And that we use, that is a constant. That's M, row 4, column 2. And then it goes back and calculates the next one. This part right here generates the 500 numbers. Right? It looks for the seed here, and it runs the linear congruential generator right there. That's all there is to it. It's a relatively short program. Then, what was much more difficult was to run the test for uniformity and independence. Okay? So this is my test for independence. Remember, that's where you have to generate the R matrix that is 6 by 1, 6 rows, 1 column. And to do that, you have to count the number of runs. And that took me a little while, I have to admit that. Because I ended up with 6 nested else if statements to do that. So what this does is it goes all the way up to 50, or all the way up to 500. It increments from 1 to 500. And it's not a very efficient program, but it runs fairly quickly for 500 numbers. So that if we go into the current row in the second column, and if it's greater than the current row, the previous row, second column, then we increment C by 1. And up here we have, remember I set R1 through 6 to 0, and I reset C to 0 too, I believe. Yeah, I reset C to 1. Okay. I had to reset C to 1 and reset X to 1. Okay, so if it is greater than the previous, then it's a run of 1. If that is equal, but if it doesn't, so if this doesn't increment, C is still equal to 1, then I increment R1. So in other words, that's a run. If this isn't the case, that's a run of 1. And then I set C back to 1. If C is equal to 2, in other words, that this met this condition twice, and I increment this up to 2, then R2, I increment R2 by 1, because that's a run of 2, incremented from 0, and I reset that C back to 1. And it continues doing that until, and it has to go through all of these nested if-then-else statements to increment R1, R2, R3, R4, R5, and R6. And then it prints out R1 through 6 into this location right here. So that we have our matrix, our 6 by 1 matrix, so that we can go ahead and then I count the number n just in case I generate more than 500. And then this is b, which is a constant, and I have a couple of intermediate, a bunch of intermediate values here, which will always be constant, but we'll end up recalculating based on r. So those have formulas in them. And then I have the Aij matrix, which is constant, and then another intermediate matrix where I have a sub ij times ri minus n times bi times rj minus n times bj. And that's a constant too, don't have to calculate it. All I need to do is put a formula in each one of these 36 cells so that it will calculate it. And then ultimately this is my R, which ends up being the chi-squared value, which then I copy back up here and compare to the chi-squared value of 6 with 0.95 for 6 degrees of freedom, which is backwards, I think I should, but anyway, it doesn't matter. And you can easily compare that. I could have even put a condition there where it compares it and says it's uniform or not uniform based on that. I didn't put that in, actually, that'd be fun. Just to, so it will tell you so you don't have to look at it actively. That's for the test for independence. That's a little bit, that was probably the hardest one to write. The test for uniformity wasn't hard at all. That's hard to write. But the test for independence took a little bit of time. And like I said, this isn't the most efficient way to go about that, but it does it in a reasonable amount of code in a reasonably straightforward way and gets the results good enough. Then the test for uniformity is even shorter. Okay? So I have M set at 100, X at 0. Because I've already declared it up there, I just reinitialized it. R is a variant, which I set to 0, and then I initialize C back to 0. So I go from 1 to M, because remember, you have to have 100 intervals, at least, for the test for uniformity to be valid. So M is a constant at 100. And then I evaluate, and this is another inefficiency, but it does it fast enough for our purposes. And then for each one of those 100, I just go through all 500 numbers and try to figure out how many are in each one of the 100 increments. So that is really inefficient. It's 50,000 passes to do this count. And like I said, most programs would have to fit if they saw that, but it works, and it's a short bit of code, so it's a little bit easier to write. So what it does is it goes to the current bin, the current it's another the current subinterval. I believe that's what they call it, to whatever our row in the second column. Evaluate whether that's greater than R, which is 0 in this case, and evaluate whether it is less than or equal to R plus 100, because these are 100 intervals. Okay, so I increment it. It starts at 0. At R, it starts at 0. 2 less than or equal to R plus 0.01. Okay, and if it's in that interval, then I increment C, and that's the end of that. And then it increments X again, and goes through the same thing, and it does that every one of the 500 times. So what this does then is that it takes the current value of C, and it writes it out before incrementing R and going back through the whole thing from going to R plus 0.01. So it takes the current value of C, which is a count of all the ones in each one of the intervals, and prints it out to whatever Y plus 8 is, and the 14th, Y plus 8th row, the 14th column. And that's where it writes, that's where we get this frequency. So it prints it out and then clears it. So it prints out that and so on. And then this calculates the frequency minus n over k, which are constants squared, and then I sum it at the end of it. So I could clear this clear that, and I can clear the R's, because those are the ones that it calculates. I can go into my program and generate, instead of 500 random numbers, I could generate 5,000 random numbers. Go back to the spreadsheet and change the seed. Let's see, I'll try 479. And to make sure this count goes to that. And now let's see whether that will run to generate 5,000 random numbers. So we can see everything. Let's do this. I'm trying to find a place to put this so it won't hide too much. Okay, so I generated 5,000. This is the run. It runs of 1 through 6. It's concentrated. The runs are concentrated at runs 1, 2, and 3, and there's much fewer as we go to 4, 5, and 6. That's good. All right. I used a seed of 479, so it's independent because 4.9 is less than 12.5, and it's uniform because 89 is less than 123. And see, so what it calculated was the R, and it calculated the frequencies for each one of the bins. And I just redid this so that it would count. It counts anything, any cell filled out down to row 10,000. So if I fill it, it'll count it. If it's not filled, it won't be counted. So that's why you just have to make sure that count function is at a large enough number so that it will capture all of your numbers. So I generated 5,000. I had it count from B10 to B10,000. So it would count all 5,000. Is that making sense? Now that you've had a little bit of instruction in the programming?
I think the third homework problem is asking for independence.
Yes.
Is this what you're looking for?
Mm-hmm. Yeah. So that's why I thought I'd spend some time going over this, because the homework will ask you to do some of this stuff. And you can use my programs, but I think that it would be advisable to go in and try to understand what you're doing. Is there anything else that you would like to see as far as examples? And these are the ones that I typically show. We go through the programming exercises, and then I run through some of the programs that I've written, just to give you some examples. If there's something that's not posted that you'd like to see, just let me know and I'll post it. Just send me an email if you find that helpful. If you have questions about programming, or what I did in some of the programs, just come and ask me. Or, if you want, if there's enough of you, let's just get together sometime before next week. And let's see, you're leaving Monday evening. So Monday afternoon, I'm free, and I could talk to any of you or any number of you if you want to. Friday I'll be around, although I have a number of meetings for this afternoon. So. Is this relatively, is this somewhat clear, or is it just so mystifying that nobody even knows what to ask? That's always a question that I ask. Both. Both? Okay, so there's some things that are clear, other things that aren't too clear.
Just sit down and do it.
This is like a language or a musical instrument. Programming is like that, you just have to practice it. It's the only thing.
On exam, are you going to ask us to write programming?
On the take-home portion, yes.
Oh.
Yeah. Not in class, no. On the take-home portion, you'll have a week to write a program, and then ask another, and I'll have another question. And the way I grade it is, you send me your Excel sheet and I run it. If it runs, I look at your code a little bit, but if it runs, then you get credit for it. I sense skepticism for some reason. I don't know why. Ask away, guys. Okay.
Let it sink in.
Okay, maybe that's better, because we can still talk a lot more about this next week. We'll be doing a review. Of course, you won't be here. But
I'll watch.
Yeah, you can watch the video, and I'll give you the problem set before the class. And then I will be circumspect in answering it, which has anything to do with the question I have in the exam, or the two exam questions. I'll hand them out to you, hard copy before class, before we or when we start. And then in 2 weeks we'll have an in-class portion, and together they'll add up to whatever points they add up to. Make sense?
So, why is programming more beneficial than just recording a macro and have it record all your steps through what you want?
Because you can't record a macro that loops. You know, you can record a macro that does elements, because that's often what I do. I'll record a macro that does one iteration, and then I'll go into the macro and edit it so that it loops. Oftentimes it is easier to write a to record a macro, but as far as I know, you can't make one loop, and you can't have conditional statements in a macro.
And it's harder to go back and find where that needs to be in the macro for the conditional statements. Or more difficult, not hard, but versus just writing it out.
I don't know how to record it in a macro. I mean, you can do a conditional program.
Well, no, that's what I'm saying. Like you record your macro and then go and add the conditional and the other statements. Is that kind of
yeah
backwards, I guess?
I don't think that's backwards, because that's often the way I do it. If there's if the guts of the loop, I'm not sure how to do, but I know that whatever that is, I want to do 500 times. I just go do it once. And then I have those guts there that I can manipulate and put inside of a loop or a conditional statement or whatever.
Kind of a copy paste type thing.
Well, I don't even do that because I just take the macro and write stuff around it. But you could do copy paste also. Well, if you feel like you want to go out and work on the two homework, as well as the practice problem set, too. The two remaining homework problems and practice problem set is what I'll go over next week. And any more programming, I'll be happy to also. And so why don't you just take a stab at those, and then we'll talk about it next week. I think that's probably the best at this point.